Today in this video lecture, we will see numerical 7 on design of shaft. See this numerical. Find maximum torque that can be safely applied to a shaft of 80 mm diameter. The permissible angle of twist is 1.5 degree in a length of 5 meter and shear stress not to exceed 42 MPa. And take capital G is equal to 84 MPa, shear modulus 84 MPa. So in this numerical, they have given us data diameter 80 mm, diameter of that shaft 80 mm, permissible angle of twist 1.5 degree, length of that shaft is 5 meter and shear stress not to exceed 42 MPa and shear modulus is 84 MPa. And from that data we have to find maximum torque that can be safely applied to a shaft safely, and this maximum torque. So write first data, given data of this numerical. Diameter denoted as capital D is equal to 80 mm. The permissible angle of twist is 1.5 degree. Length of that shaft 5 meter and shear stress denoted as tau not exceed 42 MPa. That means it is not greater than 42 MPa. And take G as 84 MPa. And to find torque that can save torque. So solving methodology of this numerical is, we will find this torque based on shear stress and torque based on angle of twist. That means by using this formula, T by J is equal to G theta by L, this torque based on angle of twist, and T by J is equal to tau by R, this torque based on shear stress. This is based on angle of twist, this is based on shear stress. We will find this torque. And see, in numerical we have data, we have this theta, we have G, we have length, we have this tau also, shear stress also, and this radius also, radius is diameter by 2. Currently we don't have this polar moment of inertia, so this polar moment of inertia we will find using this formula. J is equal to pi by 32 d raised to 4. So this is solving methodology of this numerical. And first step is this polar calculation of polar moment of inertia, then torque based on shear stress and torque based on angle of twist. We will see this numerical step by step. So write step 1, polar moment of inertia calculation. Polar moment of inertia denoted as J, and for solid shaft formula is pi by 32 capital D raised to 4. Capital D is 80 mm. 80 raised to 4. So this polar moment of inertia is 4.02 into 10 raised to 6 mm raised to 4. This is first step. Second step is torque based on shear stress. Formula is T by J, torque upon polar moment of inertia is equal to shear stress upon radius of that shaft. And this J is 4.02 into 10 raised to 6. and this tau is this 42 MPa, and radius is diameter by 2. For 80 mm is diameter, and radius is diameter by 2, that means 80 by 2 is 40 mm. So this T we get 42 into 4.02 into 10 raised to 6 upon 40 is 4.22 into 10 raised to 6. Unit is Newton mm, because this J is in mm raised to 4. Tau is also in MPa, that means Newton per mm square, and this R is also in mm, so unit is Newton mm, torque unit. And third step is torque based on angle of twist. T by J is equal to G theta by L. T by J, this J is 4.02 into 10 raised to 6. This G is this 80 MP. This means 80 MP. G is, see, in numerical, G is not 80 MP, G is 84 MP. And take this G as GP here, because in exam they given value in GPA. So 84 MPa for MPa multiplied by 10 raised to 3. 84 into 10 raised to 3 MPa. The GPA value convert into MPa by multiplication of 10 raised to 3. That means 80 into 10 raised to 3 MPa. And angle of twist is theta is 1.5 degree. This 1.5 degree, that means 1.5 into pi by 180 radian. Always put radian value in this equation. Don't put degree value. 1.5 into pi by 180 and divided by length. Length is 5 meters, that means 5000 mm. So this T is 80, here C, here also 84. T is 84 into 10 raised to 3 into 1.5 into pi by 180 into 4.02 into 10 raised to 6 divided by 5000. It is 1.768 into 10 raised to 6 Newton mm. See, now we have two torque. One torque is based on angle of twist and one torque is based on shear stress. Based on shear stress, torque is maximum, and based on angle of twist, torque is minimum. And we have to find the maximum torque that can be safely applied to the shaft. So in this safety purpose, safe torque will be least torque, lesser torque. So therefore Safe torque will be lesser torque. So between both of these, use this torque based on shear stress 4.22 into no based on angle of use based on angle of twist 1.768 into 10 raised to 6 Newton mm. Now safe torque is 1.768 into 10 raised to 6 Newton mm, and in kilonewton this value is 1.768 kilonewton meter. Thank you very much.